I want to introduce Sascha Meinrath and Theresa Dunne. We're going to be exploring some of the deeper things with some of the crunching the numbers and data. Very quick presentations, guys. But nonetheless, after that, we'll delve into a break, and then we'll come back to talk about even more data. So I'm going to leave it to them and let Sascha kind of come up and.
Hi, everyone. Sascha Meinrath. I am the Palmer Chair in Telecommunications at Penn State University. I've been in this space, this super geeky, wonky, data-driven space, since it really began, which is to say I started building community broadband networks in Y2K times. Summer of 2000, I thought this would be a cool summer project. And here we are. But along the way, I also founded the Open Technology Institute. I co-founded Measurement Lab and grew it, led it to become the largest open data repository for broadband measurement information on the planet. And because no good deed goes unpunished, I'm still playing around with MLab data and et cetera. I also helped advise, educate the folks that drafted up IIJA and helped develop the proposal for the program that we're all here talking about today. And because I like to go down with my friends, because no good deed goes unpunished, my two former employees at OTI, Alan Davidson and Sarah Morris, now run NTIA and the program that we're all discussing, which is to say, for better and for worse, I've been a part of this every step of the way. And every step of the way, we have seen consistently, pretty harmful misapplication of methodology and data, creating all sorts of havoc. Now, it's not just some crazy uppity professor saying this. The Government Accountability Office has also stated categorically that our lack of a coherent strategy at the federal level has been disastrous and will continue to be disastrous for the country. Which is to say, I have profound empathy for everyone working at the federal level, Nicole, working at the state level, Brandon, and who is attempting to build a skyscraper with a bunch of marshmallows. It is unbelievably difficult to do this. And I'm laying all this out because what I'm going to now talk about is pretty hard-hitting analysis. The mistake folks seem to make is to think that I don't want these programs to succeed, that I'm somehow critiquing the individuals involved. That is categorically false. So let me begin by saying these are initial exploratory analyses that we're looking at, but I'll bet a pint to anyone that wants to take the bet that this analysis will hold over time. And I'm also more than happy to stand up, and if I do make mistakes, first time for everything, to say, hey, we got this totally wrong. Now, let's start with the federal map, right? So we've poured $350 million into federal broadband mapping 15 years ago. We poured another $98 million. There's some other few single-digit millions that have been poured in by NTA, USDA, and a few other tens of millions by various states, municipalities, and et cetera. Long story short, we're north of $500 million into national broadband mapping, and pretty much it's all crap, which is to say, when you look at this Zoom level here, and you look at, say, what the FCC can do, what CostQuest can do with 98 million of your taxpayer dollars versus what we did with like bubble gum and a couple of paper clips for a few tens of thousands of dollars, you can see that the open methodology provides us a much more useful data store. So here we are in Harrisburg. Once you zoom in to the federal map, you can see, voila, this is taken straight from the map, and you can see, here, right here, we've got, looks like Xfinity at the 1,200 megabits per second that's available. You contrast this $98 million project with our several tens of thousands of dollar project, and you can see one important thing. Instead of just relying on self-reported information by the ISPs, which is sometimes good and often crap, You can see it up at the top. The 1200 megabits per second from Comcast is there. Well, we ran a few tests in this area using MLab, and it could be that we threw 43,450 darts at a board and missed every single time, because the maximum speed we've ever measured in this region is here. And this points to discovery. Now, this is pretty good. 70%, like the 99th percentile is 77% of what's being reported here. There's a lot of reasons why you might not get the full 1200. Maybe you're on a wireless router, maybe you choose not to get that service here. I don't have insight into why this is, but it's actually a fairly decent match. And a lot of the state is a fairly decent match. But when you start looking at discrepancies between what's reported out, which, keep in mind, this is the grant criteria for all our federal funding, not on the ground reality, but what the ISPs report. Well, when you start looking at the discrepancies between what they're reporting and what's available, you see Harrisburg's okay, but just south of Harrisburg, there's a problem. So here, anyone here from Frontier? Oh, that's a shame. So here Frontier is reporting out. Again, this is the federal broadband map, 5,000 megabits per second at this particular location. There's the address. Go look it up yourself. And here you can see we threw a couple darts at the board. We ran a few tens of thousands of tests. And maybe again, we threw 28,542 darts at the board and missed every single time. But of those tests, the fastest we ever measured is this 929 by 917, which is probably a gig service, but is definitely not 5 gigs. Not even close to 5 gigs. Officially, this all has 5 gig service. Realistically, that is simply not true. And this is nationwide, not just the state. It's everywhere we see these discrepancies. When you look at this map, all those darker red areas, right, are somewhere south of 20% attainment. The fastest speeds we ever measured don't get 20% of what is supposed to be there. This is a huge problem. You get garbage data in, and then you say, hey, Brandon, I want you to design a bespoke intervention to address not this, but a reality that's quite different, a mythology, a bias. And this leads to big problems. It is impossible to design programs to get funding where they are most needed when you don't know where those locations are. And that's what we're trying to do. Talk about a thankless task to attempt to do this, but that's what we have to do. And layered on top of that are all of these biases. The digital divide has 2 elements to it. 1, access, right? You cannot adopt broadband if it simply doesn't exist. So that obviously first criteria, it doesn't exist. What's the second criteria? Anyone want to weigh in? What's the second major component of the digital divide? If not access, once you have it,
Affordability.
Affordability. Broadband price. Nailed it in 1. So what data do we not collect nationally or anywhere?
Affordability.
Broadband price. So along with creating MLab in 2009, my team designed and proposed the original broadband nutrition label, which last month, after 15 years of battle, is finally being implemented. So for the first time ever, we'll start having pricing data. And into that space, what does the FCC continue to refuse to collect? Broadband price. So at the end of this $42.45 billion intervention, we'll still be throwing darts blindly because we're not looking at the pricing and the pricing differential and what leads to those pricing differentials. Long story short, we're solving the access problem, which is overwhelmingly a rural white problem, without addressing the affordability problem, which is overwhelmingly a poor minority problem. So when we talk about digital equity, if we're honest with ourselves, what we're talking about is one facet of digital inequities. It's the access facet. It is the white facet of the digital divide. This is not to dismiss that. It is simply to say that we are doing ourselves a grave disservice to talk about digital inequities without looking at price and its commensurate impact with communities of color. And that is the best case scenario today, is that folks will be able to build a decent, slightly leaning, perhaps skyscraper to address one facet of the digital divide, while de facto leaving other facets completely unexplored in our federal and state interventions. All righty, thank you. I'll turn it over now to more exciting information.
Good morning. My name is Theresa Dunne. I'm a community development research analyst at the Federal Reserve Bank of Philadelphia. And today I'm going to be presenting on how device access is a critical component of the digital equity ecosystem and how issues of device access can differ based upon urban and rural geographies within Pennsylvania and which communities are most affected. So just to reiterate, the views expressed here are my own and do not represent the views of the Federal Reserve Bank of Philadelphia or the Federal Reserve System. So you may have heard of this idea called the three-legged stool of digital inclusion, which allows us to envision the activities required for digital inclusion as legs, which support the larger stool. These legs are broadband, computing device access, and digital skills or digital literacy. Without one of these components, an individual cannot realize the full economic and social benefits of digital connectivity, and therefore the stool of digital inclusion cannot stand. So this has workforce development implications, as I'm sure many of you are aware of. A study conducted by the Philadelphia Fed in 2020 found a 27 percentage point difference in labor force participation rates in Philadelphia between workers with and without a computer with a broadband connection. Digital connectivity and skills can also impact a person's ability to apply for jobs, conduct online business transactions, and participate in remote work or remote learning. So while broadband certainly remains critical to closing the digital divide, I'm choosing to focus on device access today because of it's closely tied to topics related to digital skills. So first I'm going to talk about access to computing devices broadly. The definition for computing devices that I use includes smartphones, tablets, and large screen computers. From 2018 to 2022, about 92% of Pennsylvania residents had at-home access to a computing device, which is about 2 percentage points lower than the national average. Pennsylvania ranks at 44th in terms of device access in the United States compared to other states. And as we'll see throughout the presentation, disparities in device access vary across urban and rural geographies. So the following research aligns with the federal funding for digital equity planning and highlights disparities by the uncovered population groups recognized by the State Digital Equity Grant Program. So let's get into some data. I use device access data from the American Community Survey's 2022 5-year estimates. If you've seen this presentation before, I've updated it to the most recent ATS data available. So what I did was I mapped device access rates first by county, which you see here, and then later by tract. The device access rate is the share of households with at least one computing device. So what I did is I grouped the counties or tracts into quintiles based on their device access rate, so you could see which places had similar device access rates. the dark blue, the county shaded in dark blue indicate that that county has higher device access. Lighter blue indicates they have lower device access. You see from this map that the counties with the highest device access rates include the collar counties surrounding Philadelphia, as well as some other more populous counties in the state. And then those that have lower device access include more rural counties. So Juniata, Forest, and Mifflin counties are some with particularly low rates. This table presents a breakdown of the socioeconomic and demographic median values for counties with the lowest and highest device access rates, and confirms some of what we were seeing on the map. So the counties with the lowest device access rates in Pennsylvania tended to be less populous, lower income, and more white compared to those with the highest device access. So let's take a look at two counties in Pennsylvania, Berks County, which is classified as urban, and Schuylkill, which is classified as rural by the Center for Rural Pennsylvania. I chose these counties to show the juxtaposition between them. One, because they are geographically right next to one another, so hopefully that makes a little sense, and because they are a good example of how the landscape of device access can really differ based upon geography and the importance of kind of zooming in when you're conducting these analyses. All right, so starting off with Berks County. In Berks County, tracts in the lowest quintile tended to have a lower median household income by quite a large margin. Tracts with low device access also tended to have a higher median percentage of Hispanic or Latino residents, a higher median percentage of the population that speaks English less than very well, and a higher median percentage of residents with a designated disability. The blue highlighting just indicates that there's at least a 5 percentage point difference between the two values. So looking at Schuylkill County, while Schuylkill County does have lower device access overall compared to Berks County, there are not major differences in the socioeconomic and demographic characteristics of tracts in the lowest and tracts in the highest quintile for device access. But device access is not just about whether or not you can access a device. It's also about whether the device you are using allows you to perform the tasks that you need to do. So depending on a smartphone for tasks usually reserved for a large screen, not only poses immediate challenges for users in navigating websites and operating softwares, but it can prevent users from developing the digital skills necessary for large screen devices. Okay. So here we have that same map of Pennsylvania, but here we look at the share of households with device access through only a smartphone alone. So dark blue counties are counties with the lowest percentage of smartphone only households. So you could think of those counties as having better device access, for lack of better words. While the light blue county areas represent counties with the highest percentage of smartphone-only households. So those households have more limited access to devices. We do see some similarities to the initial analysis of device access rates. The area surrounding Philadelphia contains the lowest smartphone-only households, and we also see lower rates around Center and Allegheny counties. However, both rural and urban counties top the list for the highest percentage of smartphone-only households. So we see Mifflin, Forest, and Juniata all having lower rates, but we also see Philadelphia and Luzerne counties, which are both more populous. So taking a look at our two example counties, in Berks County, neighborhoods in the highest quintile were areas where at least 15.6% of households had access to a device through just a smartphone alone. And in some tracts, this number was closer to 37%. Those tracks tended to be younger, have higher percentages of people of color, a higher percentage of people who spoke English less than very well, and they had a higher percentage of the population with a designated disability. For the sake of time, we'll skip these comparisons, but hopefully they'll be available online and you can see them there. So looking at Schuylkill County, you'll remember that in terms of device access, there were not substantial differences in socioeconomic or demographics between tracts in the lowest and highest quintiles, though this is not necessarily true for the share of households with just access to a smartphone alone. So we see that tracts where a greater share of households access the internet at home through a smartphone only tended to have a lower median income, have a higher percentage of Hispanic residents, and a higher percentage of the population 19 and below, showing that there are equity issues at stake in Schuylkill County based on device access. And that looking at some of these data at the county level is really important to understanding the full picture. All right, just to conclude, so overall, the findings from this study, I think, show the nuances in device access and underscore the need for folks to really understand the landscape of device access, as well as other data that are available to inform their decisions moving forward. It's important to ask questions such as, do residents not own adequate devices because broadband is unavailable? Or going back to the affordability question, is it because maybe the devices are unaffordable? Or maybe it's a combination of both. Either way, I think the research speaks to the idea that issues of equity should be at the forefront when thinking about the decisions surrounding the digital divide. So I'm going to leave it there. Thank you so much. Here's my contact information if you have questions, and I'll turn it over to Philip.
Thanks so much for Theresa and Sascha giving excellent presentations. They stayed in the framework of their time too, so kudos there. We have a little bit of time for questions. I didn't get a chance to actually talk about Theresa and Sascha and for their impressive bio, so they're in the booklet. And if you have any other questions, please feel free throughout the remainder of the day. So as well, we did have one or possibly two questions from one of our virtual participants, Wayne. And I believe one of those questions came in prior to this panel right here. So if we have some of our other panelists from our former plenary, we might be able to answer that. But I do want to give some time now to some of our data experts here. So if there are questions that you guys want to put now, that'd be great. If we can go into some other questions.
I have a question for Theresa. So on your large screen versus small screen device slide, I noticed what to me, and I'm not deep into the data like you are, was a pretty stark difference between working age people who I would expect to be on a large screen device to do work, and people who were either probably older than working age or younger than working age. Did your data account for the demographic shift we're seeing in people who maybe don't use a computer at home and only have a smartphone because they only want to have a smartphone? I don't mean to be dismissive at all. I'm just curious if you accounted for that.
Yeah.
Yeah.
Okay. So the data that I was using was pretty just run of the mill in terms of age categories. So it wouldn't speak to the motives behind why someone might not own a computer or a smartphone. But I think that's a really avenue for, I think particularly qualitative research would be particularly useful to understanding that question.
Man.
My question is for Sascha. There are a lot of nonprofit digital equity providers around the state. There are public libraries. If folks are hearing from community members that they are having speed problems with their internet, is there a way that they can contribute to your data collection project?
Yeah, so every time somebody runs a speed test, it goes into the public domain. One of the hallmarks of MLab is our methodologies are open, our architecture is open, our data is open. Take everything wrong about how the FCC is operationalizing broadband data collection, flip it on its head, and you basically have something run fine for the research community and the general public, first and foremost. So if you go to Google, type in broadband speed test, there'll be a box that shows up above your search results. That's us. What's awkward here is getting what individuals are doing back into the official maps is a labyrinthian process. So NGOs, libraries, et cetera, are welcome to, and Brandon will probably hit this, like, please challenge the official maps and get those speed tests in, because it does allow us to officially correct what we know is incorrect. And I would be remiss to say, like, that's going to get us a fixed map, but it's just not. You would have to use fundamentally different methodologies to create the map in the first place, which we simply refuse to do. So you have to imagine that the Broadband Authority at all are, trying to fight this fight with both hands tied behind their back. Yes, you should collect these data. Yes, once you run an MLab test, it goes into the public domain, which allows us to build not just alternate maps, but show the discrepancies between existing official maps and crowdsourced data collection. And that doesn't necessarily make it into the eligibility criteria to get the grant to solve the digital divide that officially doesn't exist, but actually does. Which is to say, when the dust settles from everything we're doing with $42.45 billion, we're still gonna have all these communities that are officially served, but actually are not. Which means we're all gonna have to do this all over again, which was the caution I raised during the BTOP program of 15 years ago. And for the elders amongst us, you guys remember the TOP program of the 1990s. I was running a community technology center where they gave money and then took it away and they all collapsed, basically. This is kind of the MO. We keep doing these programs hyper inefficiently with terrible methodologies using bad data and are simply shocked that the digital divide remains persistent, evolving, but persistent throughout all of this. No national strategy is a bad way to solve this problem. And that is what we are doing.
Great, so we might have room for maybe just one more quick question for a little bit over time here. I want to give you guys a little bit of time for a break here. We have about 5 minutes. I would like to return here. Let's say like 10:37. Does that work? Shelby, I think you had your hand raised, so you just had one more question.
Oh, very fast. This is to, I guess, both of you, but I've done a lot of work with mapping in rural Kentucky, and I have found the FCC maps is a pain in the butt. They told us that a cabin that had been built in 1700s, who had maybe a light bulb, was served, so thanks for the cabin. My big question is, how are you partnering with either postal or emergency services to make sure these addresses are correct, that these are actual buildings that are actually like having electricity and internet going to them?
We're working directly with the Open Addresses group, again, an open data repository for this information. U.S. Postal Service has a number of things that are really useful for this. The problem is, even though these open data systems exist, the FCC refuses to use them. CostQuest refuses to use them. Or the FCC refuses to use them. And so you're constantly having to fight this battle where enclosure of what should be public data keeps happening. And yeah, I feel you. Like the amount of silliness in these data sets is ridiculous, given that we've, again, spent $500 million with a B dollars on broadband mapping and keep making the same mistakes year after year, decade after decade. The best case scenario is that you get a critical mass. And this is where our state government, is anyone here from the governor's office by any chance? Right, because like the feds have no plan, which basically means the states have to like make a coherent strategy, and yet our state simply refuses to give something besides marshmallows to Brandon and company, right? Like, we need to make investments in public data, in open data, in clear-cut, transparent, methodological information, so that we can build a better needs assessment, the state, federal, whether it's Kentucky or PA levels. We simply refuse to do that. It's mind-boggling that we do. We're going to spend orders of magnitude more money and then have to spend even more money because we spent the original pots of money not incorrectly, suboptimally. But we can talk more. We have lots of open data sources. All of my work, all the data from the Internet Explorer, there's all Creative Commons 0 data. So you can do anything you want in Kentucky and elsewhere.
And we'll have plenty of opportunity, I think, throughout the remainder of the day to also talk as well. So